Algebra 1 Lesson 84. We are looking at our quadratic functions, those trinomials we've been working with, and determining, do they give us our parabola, or maybe do we have a cubic function, or maybe just a linear function with what we are given. So let's see. A quadratic function is a function that can be written in the form of f of x. We typically call that y. Okay, but f of x equals ax squared plus bx plus c. And a cannot equal 0. Okay, this is the form that we've been looking at for a while now, especially being able to factor these trinomials. Now, we have also found with our polynomials the degree of each. And remember, we find the degree by finding the degree of each monomial. So for example, in the second one, let's say, the first monomial has a degree of 2, the second one has a degree of 1, and my constant has a degree of 0. And we say the degree of a polynomial is whatever is the highest degree. So in this case, the highest degree is 2. And we have specific names for these polynomials if they have certain degrees. So a degree of 1, like 2x plus 1, is just linear. If you imagine if we had a y equals 3x plus 2, we would say 3 is our slope and 2 is our y-intercept. If it has a degree of 2, we say that's quadratic. We base that on the highest degree of any of the monomials. And same with cubic, but the degree is 3. The highest degree of any monomial is 3. We call that cubic. So let's identify what these are. We first, though, need to put these in standard form, which means I'm going to get y by itself and put them in order from least to greatest degree. So I subtract 7x in the first one, and I get y is equal to, all right, highest degree is 4x squared, and then comes negative 7x minus 6, which means this has a degree of 2, which means it's quadratic. Okay, second one on the right, we add 15x to each side to get y equals 15x squared plus 2x plus 3, meaning that degree of 2 makes this quadratic. I can't spell this morning, I'm sorry. Quadratic, okay, you get it with the Q. All right, and then next one, y equals 5 plus 2x. Let's put that in standard form. So we put 2x first plus 5. It only has a degree of 1, so that means this is linear. Next one, we want to get y by itself, so I'm going to subtract 8x. Okay, so we say y is equal to, I'm just going to flip these around, 9x to the 4th minus 8x minus 9. This has a degree of 4, which means that it's cubic, it's not quadratic. Some people have a name like quartic for it, but that's not super common. It has a degree of 4. Okay? And then the next one, we add x to the 3rd to each side to get y equals, well, add 2x cubed to negative 5x cubed. We get negative 3x cubed plus x squared. That degree of 3 makes this cubic. Okay, and lastly, we add 62 to each side to get y is equal to negative 2x plus 65. This is just linear. Okay, now focusing on our quadratics, we have a way to describe the path of these functions, and it's called a parabola, because it's this U-shaped graph, very nice smooth curve in a U, and it actually continues on forever and ever. This is our parent function, meaning all of our other quadratics are based on this function right here. Where if we take y equals x squared, put it into a table, we would say, all right, let's say we have a negative 2, negative 1, 0, 1, and 2. Well, if I do negative 2 times negative 2, I get 4. Negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. You can see some symmetry between those y values. Okay, and so when we plug it on the graph, we will see these points at 0, 0, 1, 1, 2, 4. Negative 1, 1, and negative 2, 4. Okay, this is our parabola. Now, if we have something slightly different, okay, it's actually been stretched a little bit and reflected. We have f of x equals negative 3x squared. We want to plug some values into our table and then graph them. So I'm going to pick negative 2, negative 1, 0, 1, and 2. When I plug these in, If I plug in negative 2, I'm going to get negative 3 times negative 2 squared, so I get negative 3 times 4, which is negative 12. Plug in negative 1, get negative 3 times a positive 1, which is negative 3. Plug in 0, I get 0. Plug in 1, I get, again, negative 3. Plug in 2, I get negative 12. Now what you'll notice about this, we still have this point at 0, 0 because we haven't translated it anywhere, but now we are actually going down. Okay, we're going to have points right about there. And we still have this nice, smooth parabola, but it is extended downwards. Okay, and that comes because we have reflected it with that negative in front of my x squared. So to say this more succinctly, if our a value in front of our quadratic term is greater than 0, if it's positive, it faces upward, just like our parent graph. Okay, it looks like a normal U. But if a is less than 0, if it's negative, the parabola faces downward, like the one that we just saw. So let's see what happens with 5x squared minus 3. And I'm going to plug in negative 2, negative 1, 0, 1, and 2. We want to see the whole thing. Okay, and maybe I'll do 3 as well. So if I plug in negative 2, I get 5 times negative 2 squared minus 3, meaning I get 5 times 4, which is 20 minus 3, which is 17. Okay, next one, 5 times negative 1 squared minus 3. Well, I get 5 times 1 is 5 minus 3 is 2. Okay, plug in 0, I get negative 3. Plug in 1, and I get 5 minus 3, or 2. Plug in 2, and I get 17. And I'll actually skip 3 for this time. Meaning, when I do this, I am going to get a upwards parabola, but it's going to be shifted down a little bit. Okay, so let me just plug these in. We're going to have something way up here. All right, so we have this really skinny parabola just like that. Okay. All right, so looking at these parabolas, we want to determine the direction, and it's all based on this quadratic term. So we say, is that positive? So this is upwards. Okay, we once again look at the quadratic term, and it's negative, so this is downwards. Okay, couple more here. We say this one, it has a positive a value, so it's upwards. Negative value, so it's downwards. Okay, put those in standard form, and it'll help you out quite a bit. Okay, and lastly, if we have this quadratic and have some information, all we're doing is plugging it in. So if I have 256 minus h equals 16t squared, if I want the height for 2 seconds, I could flip this around so that I have h by itself, get 256 minus 16t squared equals h. I just flip the h and the 16t squared, and I plug in 2 for t. So I get 256 minus 16 times 2 squared. And you can work that out for yourself and figure out what the height is at 2 seconds. Here's one last problem you can try. And I hope this is helpful for your homework and for studying.